So another really important topic that we need to cover in regards to probability is the idea of sampling from a small population. And this is really looking at repeatedly pulling an observation from a small population, whether or not we are replacing that object back into the pool to be able to be eligible to be selected in the subsequent selections, or if once it's selected, it's not replaced and it's completely removed from the sample. So let's look at our first example, which is looking at sampling with replacement. Suppose that you work for a call center with 7 other individuals and you receive a call from a very difficult customer. What is the probability you will be the one to answer the phone when this customer calls back later in your shift? Now, we're assuming that phone calls are assigned randomly. So the probability that you were the one to get that customer in the first place was 1 out of 8 because there are 8 of you working at the call center and the calls are randomly assigned. Now, since taking the call from the customer previously has no influence as to whether or not you're randomly assigned this customer again when they call later in your shift, you still have a probability of getting 1 out of 8 when they call back the second time. So the probability that you get the customer both times, we can use the law of multiplication of independent events to find that the probability of you receiving that customer's call both times is 0.016. Now, the concept of sampling without replacement means that as I have an occurrence, that occurrence is no longer eligible to be selected on the second time we make a selection. Okay, so here we have an example where you work at a local shop that's been struggling in the recent economy, and they've let you know that they need to let go one of their 10 employees each week for 2 weeks. So what this means is that we're going to eventually let 2 employees go, but the second employee gets to work an extra week. Okay? So what's the probability that your friend is going to be that first person let go and you're going to be the second person that is let go? So there are 2 approaches you can take. The first one is you can determine the number of possible scenarios by using the permutation rule. And so by using that permutation rule, you find that there are 90 potential scenarios of one person being the first person let go and another individual being the second one let go. And so your probability of this very specific ordered event happening is 1 out of 90. Okay? The other way you can look at it is by using the multiplication law of independent events. So here, the first time someone is let go, there's a 1 out of 10 chance that your friend is the person let go in that first round. Now, the second round of people being let go, there's only 9 people that work there now. So you have a 1 in 9 chance of you being the person let go on the second week. So using the law of multiplication for independent events, you have a 0.01 chance of being selected in that order.